So, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong and Precisely. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we do have an exciting presentation for you ahead. First, I do have just a couple of housekeeping notes to cover. Today's session is being recorded. If you miss any of our session, or maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab, which can be found on the right side of your screen. That's also where you're going to find the chat tab, where we want you to direct more general comments, or maybe if you just want to let us know from where you are tuning in. In the handouts tab, you'll find a link. This link is present on the final slide of the presentation. So if you'd like to check out that link for your convenience, that has been added to the handout section. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of today's program. So on to our topic. We'll be discussing keeping the pulse of your data and why you need data observability. I'm joined today by Paul Rasmussen, Principal Product Manager at Precisely, and Shalaish Koul, Principal Sales Engineer at Precisely. So Paul and Shalaish, thank you both so much for joining me. Paul, do you want to go ahead and get us started?
Thank you, Cody. Thank you for the introduction. I'm happy to be here. Thank you, everybody, for joining. We're going to be talking about data observability. My name is Paul Rasmussen, the Principal Product Manager for the Data Observability product at Precisely, and I'm joined by my colleague, Shalaish Koul, who is the Principal Sales Engineer. So data observability, some of the topics we're going to cover: introduction to data observability and the concepts, why now, why we're talking about now, some typical use cases with a demo within our product, the overall approach with the data integrity suite, some question and answer at the end. So let's get started. Data integrity. You can certainly find any number of articles and surveys in the press or analyst reports that dig into this issue of data integrity. Here you see just a few stats from Forbes, Harvard Business Review, and Precise's own data trend survey. When 2/3 of organizations say siloed data negatively impacts their data initiatives, and almost half of newly created data records have at least one critical error, it is no wonder that 84% of CEOs doubt the integrity of their data from which they make the decisions. So the first question you probably have is, what is data observability? Data observability ensures the reliability of your processes and analytics by alerting you to potential data integrity events. It answers the question, is my data ready to be used? And what do we mean by the term used? We mean anywhere business depends on the data being accurate. This obviously means a lot of different things to a lot of different people. For example, if you're dependent on a business intelligence report, you may ask, is the data feeding my reports correct? If you're a data engineer or in IT moving your data through ETL or ELT pipelines, you might want to know if the data is being transferred correctly. And lastly, if you're a data scientist or in the DataOps world building advanced data science models and analytics, you might want to know if the models are reflective of data changes and need to be retrained over time. I'll take, for example, a simple process where in a finance department where it's making business decisions based on a daily report of online orders. If for some reason the data feeding the report from the source systems is incorrect, the insights and outcomes based on it are flawed with obvious negative downstream impacts. So in today's world, how do in this really complex business world, a complex ecosystem of many parts, we see a mind-blowing number of accomplishments across every industry and vertical. Take, for example, semiconductors, where we're putting trillions of transistors on something less than a square inch. You've got auto companies. How are they building a car on a production line with 30,000 parts spanning different raw materials and manufacturing processes? So we've got software and data engineers, and they're developing, merging, and employing millions of lines of code and near real-time continuous delivery pipelines. And it's pretty amazing what we're building today. So what do these processes and systems have in common? The data observability. What we're looking at is they all share a set of common principles based on the concept of observability. What really started as a revolutionary new idea in manufacturing almost 100 years ago has evolved into a staple of the modern industrial age. If you work with many of the quality improvement tools such as SPC, Lean, Six Sigma, and many others, you've come across it. Essentially, this applies to any process that builds quality into its final product. Some key themes of observability include continually tightening your limits in flagging data issues. Flagging essentially means notifications, escalations, and routing of potential issues to the right folks, be it data operations, business operations, data owners, and stewards. The other one is identifying different types of issues, often referred to as either special or common type issues. An example of special is a system outage, which maybe is not that common for you, or a common one such as a bad reference data in a typical data pipeline. It gives you context into your data by augmenting it with additional attributions such as lineage, sourcing, and parentage, including other things like ownership of the data, downstream impacts of data issues, and many others. And finally, it triggers next steps and actions, such as the retraining of a model, stopping a data movement pipeline, or notifications to stakeholders to take action. You really find no shortage of observability tools, use cases, and success stories by simply looking around. So why now? We all know that businesses are using data for more purposes and ultimately becoming more dependent on it. I liken it to the example of driving a car with our phones, and that our primary goal is to get safely from point to A to B, but we're constantly inundated with distractions when all we want to know is where we are and if we're making a wrong turn. We know our primary job is to get the car safely to the destination, but then we're overloaded with this information and really can be overwhelmed. The same applies to data in your business. Your objective is to run your business, but you're constantly distracted worrying about your data integrity issues. The reasons for these vary across industries and verticals, but at a glance, they really can be grouped into two different categories of data proliferation and technology diversification. And what do I mean by both of those? So by data proliferation, I simply mean more data. A Forbes study estimates we're creating about 2.5 quintillion exabytes of data every day. And this data is spanning a variety of locations, such as cloud, on-premise, hybrid cloud, and not to mention the movement of data across all of these locations. And by technology diversification, I mean pivotal business transformation initiatives that are empowered by this amazing next generation tech. Or we think of established legacy systems. These efforts almost always span a diversity of vendors, applications, and technologies, such as streaming, IoT, AI, and ML. But on the flip side, with this data proliferation and new tech, we have solutions to make our lives easier and free up our time for more productive activities. Data consumers and producers cannot take their hands off the wheel to validate all of the data is ready for use. Business value is not only created when the fast insights allow for quick decisions, but also when the data being used for the insights is trusted. So with the changes described in the prior slide, the processes managing the data lifecycle and data journey in a modern enterprise has become incredibly sophisticated and complex. It is not out of the ordinary to see 1,000 pipelines and transformations spanning hundreds of data sources, with data integrity and quality validated at the final delivered stage. Compare this to a traditional manufacturing process, it's the equivalent of ensuring the quality of the finished product with a post-manufacturing inspection of the product. The pick and pull method, the random approach, where somebody picks something after it's come off the assembly line and then checked it for quality. And as you can imagine, this process is incredibly costly from both a time and a risk, cost of goods and cost of materials perspective. The same concept applies to your typical data products, such as analytics, reports, applications, and any pipelines or processes driving an outcome. And the result is the same. A stakeholder finding the issue, reporting it to the creator of the pipeline and the analytics, and having to go back to resolution, going into the life cycle of resolution. Modern data and DevOps are great at implementing quality at the time of development, but often neglect this repeatable process that happens every day to generate their products that their business users, their stakeholders, or customers are using. So what does this look like with observability? So data observability enables the user to visualize the data process and see deviations from the typical patterns that really exceed their expected limits. What that means in this example, you see a typical data process that spans multiple data sources and transformations. This is a pretty simple view, but in reality, there could be hundreds of different transformations spanning many different data sources. And as it moves through the pipeline, it is observed at each stage, ensuring the entire process is stable. In data source number 3, as you can see, is applying enrichment, blending, and merging of the data. We can see that there's an anomalous condition that has the potential to jeopardize the final data product. By catching it early in this stage allows the appropriate resource to be notified, assessed, and resolve the issue before the data is made available for consumption. Many studies have been published validating the cost savings of finding issues earlier in the life cycle. In some scenarios, the cost impacts were very, very significant. We've even seen examples of introducing a random data issue into the development process just to see where the process breaks. The observations employ a spectrum of methods to identify if the data is conforming to the historical patterns of acceptable data. If a variation is detected at one of the stages, it can be remedied before it impacts the final data product. The early resolution eliminates wasted time and resources in latter stages of the pipeline, not to mention the risk of negative business outcomes. Okay, and with that, I'm going to hand over to my colleague, Shalaish, who is going to show this in action.
Hey, thanks, Paul. Hello, everybody. Good to be here. And I will take one of the examples of a real data pipeline in our application. And this example is very closely related to what Paul's been talking about. We're leveraging observability to basically track all the data and capture anomalies. So what you see here is a technical lineage of a data asset that a data pipeline that we have in the application. As you would see, there's CRM, the Salesforce on the left-hand side. We're pulling data from it. It's going to a Snowflake environment, stored there in a table. It's going through some transformations, and then it's going to another table, and eventually it's landing in a Tableau report, which is used by the C-level executives. And this is a typical journey of the data, and there are more complex than this. We chose something very simple. As you would see, the details on the right hand side pane, you've got all the metadata related to this particular data asset, the order amount, the different details around it, where are we observing it, the asset, the paths. So what we want to focus on is we have a bell icon over there which has an alert on this. So what we did as part of this data pipeline, we've been observing it not in pieces, but holistically. So while there are checks which are done at the time the data asset is created, but while there can be checks when we actually create the end report, like the data product Paul was talking about, and you can find anomalies in that and then kind of retrofit that into how that data even got there. But we're taking the holistic approach and we're leveraging observability for that. So we're monitoring this data while it's moving through these different applications. And what we see here that there's a data drift. Now, a data drift can be something we'll get to explaining all these things in a little while from now. But data drift essentially means that data is not conforming to how it used to be. So if I had a pattern historically, how we're seeing this data come in, there's a deviation from that. So now this data anomaly can have varied impacts. So what I'm going to do is I'm going to pull the impact of this and show you that a small data anomaly can have massive impacts. So I'm going to go to the impact diagram. It's another view how we see how data assets and are associated and what relationship do they have with various other things within the enterprise. And those are the the different processes. There's an order process which is associated with this. There is organizational goals and objectives which are associated with this. We've defined goals based on how this data is going to be there. So this one anomaly can have a massive impact on the overall enterprise, because we want to make sure that those goals are aligned and the data that those objectives are using to fulfill, if that data is not correct and trustworthy, we're not going to get the outcomes that we are expecting. So how are we doing this? How are we observing all of this? So I'm going to jump over to show you how I set up observation on top of this data pipeline. So I have the process here where we have defined there's observers, and I have the process, my observer, the financial close process there, which I'm actually looking at and making sure that I observe this data pipeline. So if I'm going to edit that process, let me walk you through the things that I observed there. So here are the details. Here's my table. Here's the different columns, and all of them, I'm observing all of them. Now I have the option to observe just the order amounts, but I'm observing all of them. It's just that the anomaly we found was in just one of these columns. And once we actually look at the key metrics that I'm observing, we will see that I'm looking for two key observations. I'm looking at the volumes and any unexpected changes in the volume of data that I have seen historically, and the data drift, any non-conformities with how I have seen the historical data come in. And these are the two key observations that I want to monitor throughout my data pipeline. All right, back to you, Paul.
Thanks, Shalaish. Okay, now that you everyone has seen kind of the macro level picture of where it fits in, we're going to look at specifically some of the benefits of data observability. The first one is the understanding of the data health. That really means, it's by continuum measuring and monitoring of those data assets. The visibility, we saw the full context of that data in the data landscape, where it fit in. He showed you the lineage and the impact, and allowing users really to do some self-service as well as automated active resolution. Receiving the alerts through different mechanisms. Obviously users don't have time every day to sift through alerts. It would be notifications directly to inboxes, to third-party applications. To resolve the data drift and shift when identified by intelligent analysis. And I'll show you that in a second here. It enables a quick remediation when you understand the context and the cause of the data integrity event. Allows a resolution much quicker than a typical kind of hunt and peck and find the issue in a data exploration. Okay, and the ultimate goal of data observability is to fix data issues before it is consumed. And this is really done by shining light on the potential data, the data issues with an unintrusive user interaction. This slide really captures the essence of data observability and just how simple it is to kind of shine the light on potential problems and change course versus having to salvage the wreckage. If there's one takeaway of this webinar, please remember that data observability is proactive and intended to reduce the data downtime. It uses a variety of techniques as well. Data observability surfaces these issues in source systems before they become significant. We're going to show you a few examples of those today based on volume and data drift detection methods that answer the questions such as, is my data ready to use? Do I have all of my data? Do I have the right data? And will data structures break my data? And with the data proliferation and technology diversification at play, like we discussed before, the reactive methods simply do not scale, are error prone and resource intensive. And as the old adage goes, an ounce of prevention is worth a pound of cure. So the first question we often get asked is how does data observability relate to and differ from data quality? And the simple answer is there is some overlap. And in your organization, they may be under the same umbrella, since they both really focus on the use of metadata and the traditional data quality dimensions of data quality, such as accuracy, completeness, conformity. But the biggest difference is how data observability goes about it. Data observability emphasizes the identification of anomalies in data based on patterns over time, similar to the human inference versus static predefined rules that work off defined metrics and failure scenarios. By using a time series graph of history to predict those expected ranges and forecast values, a pattern of seasonality can be inferred to discover anomalies and ultimately leverage the metadata to alert users and take actions. In the data integrity suite, we break out observability and quality into separate and distinct modules. But we also make sure that both capabilities complement each other versus compete and share key capabilities. You basically have one place to do both. So how does data observability work? It's really broken down into three main capabilities for data observability. There's the discovery piece. The first step is really essentially discovering the data that you want to observe and collecting information about those assets through a variety of techniques and tools. The second component performs the analysis to identify the adverse data integrity event. The analysis can get quite sophisticated and often implements modern AI and ML methods to crunch massive amounts of metadata and related information. And finally, is the third main capability, and that's bringing those alerts and insights into action for both manual and automated resolution. It's essentially the step to do something about the data issue. I'll tell you about the intelligent analysis. So what isn't obvious when discussing the analysis components of data observability is the extensive intelligence powering those insights. For our data observability product, we chose to use outlier detection for identifying anomalies as it's proven to be a really effective technique in many use cases, spanning data prep for machine learning models. It's pivotal in data analysis and root cause analysis. And it has really become the application of use cases is virtually limitless. So here are a few typical patterns. That's really just kind of scratching the surface of some of them. Examples of trends included in the models are random noise, step changes, both upward and downward trends. Not to mention many more complex scenarios that include trends based on seasonality, or bias towards seasonality, and nuances between data types such as numerical data, character data, and dates. So as we go through the demo, hopefully you'll pay attention to just how intuitive it is to use. We put a lot of effort into making the user experience very easy. Using some key principles such as point and click, no code, functional defaults, while also making it extensible, tunable, and configurable. So with that, we are going to go back to the product and show you a few more examples of what we're talking about here.
Hey, thanks, Paul. As I promised, we're gonna come back with the details, walk through the use cases that we thought will be quite relevant and for everybody who has knowledge about observability and how it works, and for people who are new to the concept. And we've chosen these examples, which are real use cases that have happened across a plethora of our customers, and they're quite they're quite easy to follow. So one of the examples was where an incorrect currency type in the order inflated the revenue amounts multifold. And this error was caused because the currency conversion table was not updated. It's a classical example of multiple stakeholders managing the IT environment, where you have multiple places to update, to synchronize before you introduce something new. A new geography was expanded for the customer base, and the orders came in a new currency, and that was accounted for in most of the systems except for one, and which caused a problem. And this is something that you can relate to in any industry that you work in. There are multiple touch points within a data pipeline, and they all need to be in sync. But sometimes we just can't get it all there, and that's where observability kicks in because it's watching all those different touch points, and it can tell you that, hey, here's a problem which is caused, and then you can start looking at the root cause and finding out and taking care of the problem before it becomes catastrophic. The second example which we have is again around the similar concept. We had a huge spike in the dollar amounts because of the same reason. We're piggybacking off the previous example. It was expansion into a new geography, and we got a single day spike because more orders came in, which was a legitimate case because we are going to expand our territory, so we're going to expect more customers. But we still alerted the customer and the stakeholders so that they can actually see it and see the impact it had on their orders portfolio. Then we will dive into the last example of the day, which kind of gets to the foundation of how it all happens. The data exploration through self-service, as Paul was talking about, an intuitive platform where people who actually own the data, the business around them, where they can go in and check on the health of their data, where they can go in and understand the different metrics around their data, and those are not technical metrics. Things like how good is their data, how complete is it, how unique is it, what is the other metadata that surrounds their data, what inconsistencies do they have in their data, and how would they become privy to all that information. And it because they can't go and run queries on that, and they don't have the technical skill set that it takes to look at the data lake and understand those things. So how do we present it to them through self-service and easy and intuitive way? That will be our last demonstration of today. Thanks, Paul. Now we can jump back to the application. All right. So as we were talking about, the first example. The first example, we're going to talk about the currency. So as you see, this is our observability, and this is where you see all the different alerts that come in. And we're going to focus on this alert, which was raised on September 7th. And there is details around the alert. So you can look at the alert level, which is critical, and we'll walk you guys through that. What does that mean? There's an alert type, that's the data drift. There are different statistics that are impacted as part of this alert. And then there's asset information that this happened on the currency. And then if you actually go into the details of the actual alert, you will find out all those details. But a very easy way to analyze this is if I'm looking at this line chart. I can see that there's a cardinality which we are tracking. And the cardinality jumped from 9 to 10 on September 7th. So what does that mean? We had only 9 currencies till September 6th. I can expand this span to go back in history and look at further down a year, a month, and look at my data. And I only had 9 different currencies that we were taking orders in. And on this date, the cardinality increased to 10. And the observability automatically detected that as an alert because this was not what was happening in the past. So we got an additional currency which we had never seen before. And and how many things that can impact. We were earlier looking at our impact diagram and showing how many different systems can be impacted. Our second alert is directly related to this. So I'm going to go to the order amount. Because of the introduction of a new currency, the same alert, there's another alert which got created around the same time. And what we're looking at here, there are 3 different individual statistics that got impacted because of this. The maximum value of order amount, the mean, and the standard deviation. So if I'm going to look at the different values that came in before the September 7th run, I can actually look at the data. While I see there is the maximum value on an order used to be around 12,000. And that is how the historical pattern was. And when I look on this date, the maximum value is 207,000. That's a massive increase in the maximum value that can come on an order amount. And while that definitely sounds like a data anomaly because that's just not normal, we're not only capturing anomalies which are this significant. And I'll walk you guys through once we go into the alerts to see how we can configure those alerts. But a lot of this is driven by intelligent analysis, which Paul was earlier alluding to, where we associate a different level of confidence based on how deviated you are from the normal. So let me go to the third example where we're going to talk about the alert. So there you go. So this is an example of the volume alert. So while we were looking at the data drifts in the previous two examples, this is the example where we're looking at the volume changes. So volume changes are far easier to understand because if I'm running a business, I typically know that how much volume of data do I expect on a day-to-day basis. And if I'm deviating from the normal, I need to capture that. And observability works pretty much the same way. It's looking for historical trends and patterns of the volume of data that comes in. And if we see a significant spike or an upward spike or a downward spike in the volume of data coming in, I need to get alerted. In this example, we'll see that the volume actually jumped from 10,000 to 18,000. That is an 80% increase in the volume. Now, in the last example, we had almost more than 1,000% increase. We still got alerted. Over here, we have 80% increase, and we're still getting alerted. And that's the decision which the AI engine makes for us, because although the anomalies are significantly different in terms of their variations, but we will be alerted on both the scenarios. So let me walk you guys through the configurations of how we set up these alerts and how do they actually work. So I'm going to go into one of my existing observers, and here I have two observations: the volume and the data drift. And I'm going to go to the data drift first to show you how many different metrics are we actually capturing as part of this. So as you see, we're looking at the numeric data, the textual data, the distribution of those value counts. So it's looking at multiple aspects of what can come in from your data perspective, the content of your data, and it's measuring it against what has historically been coming in. And then you have these different alert levels. As you see, there are three different categories, and I can toggle them around according to my use case, according to how I understand my data, and I can set it up. And the AI engine will actually run and associate a confidence level with every alert. Same goes for the volume. I'm looking at the deviation from the normal. And again, there are different categories in here, which I can change the thresholds based on what I consider critical and what I consider as a warning. But AI is great, but sometimes we like to think that our customers sometimes know their data more than the machine can understand it. So I love that we always have an option to create those threshold based alerts, because I know my data more than anyone else. So I can set up my environment and I can configure it on the metrics automatically, like moving averages, like the last profile run, compare it with what happened yesterday. I don't need to go far because I know I only care about the day over day. Or if I care about the past, I'm going to look at the moving average, and I'm going to set up my own threshold levels. And think of the example that we talked about. The number of orders that came in jumped from 10,000 to 18,000, 80% increase, definitely alerted. But what if it was just 11,000? And I want to be alerted because I do not expect a 10% variation. I know my business does not, it has a threshold of 5%. That's the amount of variation which I consider normal. And anything above that, I would like to be notified. I like to be alerted, and I want to make sure that that's not because of a data anomaly and it's just business as usual. So I love that that option is available where I can set up my own thresholds and not rely on AI and ML to make that decision for me. I hope you guys found that interesting. I'll hand it back over to you, Paul. Take it up from here.
Okay. What about that last use case? What about the data exploration? So what does that look like within the observability product?
So from a data exploration, sorry, thanks for reminding me that. So the data exploration is all around the self-service that we want to provide our customers, actually, that how do they go in there and understand their data, and especially for the business folk. So these are the multiple profiles that we have run on our data. So if I go in there in one of these profiles, I can schedule them. They're running on a pre-scheduled basis, and I can dive into the details. So what this is doing, it's telling me on the entire table, the data set level of what are the different metrics. So if I go back to the table, I go back on the table level, I can look at different KPIs like completeness, uniqueness. I can look at the null counts. I can look at the semantic classification that we have identified. Things like the mins, the maxes, the averages, the moving averages. And this gives me a holistic view of how my data is. What are the different attributes? Which ones are complete? Which ones are not? Where do I have the nulls? So I can perform all this analysis on my data without even asking for help from anybody. And then I can drill into individual columns, individual attributes. Like this was the currency which we were talking about. So although I have all the things which I can see on the table level, I can also see them on an individual column level. Things like script distribution, string length, the frequency analysis, the pattern analysis. So if I go down, scroll down, we can see the different patterns that the data is coming in. We can see the different character categories. And while we're looking at this, I want to kind of use this to show you the example that we were earlier talking about. So if I go to the frequency analysis, I can actually see the multiple currencies that have come in. And as you see here, there's a Japanese yen, which is there. And we had 1,754 records of a Japanese yen on today's run. But if now I'm in the previous day, now I'm on the previous day, and there was no Japanese yen. And this is what we were earlier alerted on. As you can see, the Japanese yen did not exist as a currency the day before. So the observability told me exactly the same thing and alerted me on it that, hey, this Japanese yen got introduced as a currency on your orders on this date, so you should know about it. And I can validate that over here by actually looking at profile for today and the day before. So this tool gives me so much more information about my data without having to reach out to anybody. All right, Paul, back to you.
Okay, thanks, Shalaish. So just a quick recap on the use cases. You saw how data anomalies were impacted from downstream processes. You saw the impact of unexpected values for the currency type. You saw unexpected data values caused by the lack of communication internally and how to kind of distribute that information or collaborate with that information. And the self-service data exploration, how to uncover the inconsistencies and do the conduct analysis themselves. So what you saw was the Precisely data integrity suite. And at the foundation of the data integrity suite is the need to deliver trusted data to people and processes, but ensure it is accurate, consistent, and contains context. We look specifically at the data observability module. But keep in mind the Precisely Data Integrity Suite is a set of 7 interoperable modules that enable your business to build trust in your data. This suite has been built so that you can start wherever you are in your data integrity journey. This means that the modules are designed to be implemented either together or standalone on their own with best-in-class capabilities. For example, you can start with data observability and layer in other modules over time, or start with another module and then add in data observability later. It's important to note, really this webinar was focused on data observability. It really very briefly covered some of the other features and capabilities. And thank you for attending the session. We are going to hand it over to any Q&A. So Cody, take it away. Do we have any questions from the audience?
So we absolutely do. Our first question reads, how does data observability work with other applications?
First and foremost, data observability should work as either a standalone application But really what we're seeing is the customers that integrate data observability into their processes and technologies, existing process and technology stacks, see the most business value. So for example, when integrating data observability with your catalog or with governance or quality analytics, really your data movement pipelines, ELT or ETL, it really ensures that your solutions are interoperable. And interoperability being really a fundamental tenet of the modern tech stack. And that's really, given all of the modern applications have services that are open and available to be extended, enhanced, enriched. So really the product works as standalone, but really meant to be interoperable within the entire your technology stack.
Perfect. Thank you for that. Our next question reads, how is observability in DataOps different from observability in DevOps?
Really, the concepts remain the same. Really, you're observing, monitoring, measuring, and taking action. You're providing visibility into repeatable process. The DevOps is a repeatable process. Same with DataOps. And that's not just the development piece, it's those operational components, the repeatable process that we talked about earlier in the presentation. It really indicates a DevOps, your focus is on tasks related to the development of applications. In tasks, and with data observability, your focus is on really tasks and systems focused on data and its impacts. The same goes for other XOps type things. For example, application monitoring, application performance, and data observability are very similar as well. But the biggest difference is that the applications tend to change far less than the data. Data changes rapidly, changes on an hourly, a daily, a minute, a second, a microsecond by microsecond data time frame. Data is changing in your environment. Those are the biggest differences.
Great. Thank you. It looks like we have one more question. So it reads, what type of user would you expect to work data observability alerts?
What type of user? I think the first point is that all users can benefit from richer view of their data assets. What we're seeing in the market is data being used everywhere. Traditional roles and responsibilities are getting blurred. Before, where you might have had one person that was dedicated to data, you're seeing that you span across the organizations as users become more sophisticated, as they're expected to do more with the data. So this means that the typical user of data observability is really expanded beyond just a resource that is just responsible for monitoring the data in an operations role. I guess one example would be think about a CEO that benefits when they feel confident in their analytics to make decisions, or a data scientist that benefits when their models are more accurate and they're giving the business better insights, more accurate insights. And somebody from operations who really sleeps better when they know when their systems are running as designed and functioning properly. That means a typical user of the alerts is going to be somebody responsible for delivering trusted analytics and data. We're seeing this role fulfilled more and more by folks categorized as DataOps, and this where the persona that fits into that silo is, you'll hear titles like data engineers, data analysts, data stewards, analytic developers, and such.
Awesome. Well, Paul, that looks like it's all the questions that we've received so far. So I'm going to go ahead and give you the floor back in case there's anything that you'd like to say before we close out.
I'd like to thank everybody for attending this webinar. I hope you found it useful. If you are interested in learning more about data observability or about the products that we demonstrated for you today, please take a look at the link below, or get in touch with us.
Awesome. Well, Paul and Shalaish, thank you both for joining us and for walking us through the demo and through your product as well. A quick reminder to our audience that today's session was recorded. So following this panel, you'll receive an email with a link to access the recording on demand, or you can find it living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. So at the top of the hour, we mentioned we'd be giving away 4 $25 Amazon gift cards. Our first winner is Roham A. Our second winner is Stephanie M. Our third winner is Rao P. And our fourth and final winner is Nakisha N. So to our 4 winners, congratulations. Please keep an eye on your email inbox to claim that gift card. But if you do not see an email come through, please monitor your spam folder. So thank you to Precisely for sponsoring today's program. And to our audience, thank you so much for joining us today. We really appreciate you spending time with us. We do just ask for 1 extra moment of your time for a brief post-webinar survey that should pop up on your screen as soon as we close out. But otherwise, we do hope to see everyone at an upcoming Techstrong Learning workshop or webinar. Everyone have a great rest of your day.